we move on to lipid rafts. And I got really excited here because this is one of my favorite topics. So let's take a listen. And here we go.
Peter was just talking about that fatty acid makeup in the phospholipids becomes so crucial because saturated fats are straight, they're rugged, they don't bend. So it gives some structure to a phospholipid. If your phospholipids contain a lot of saturated fat, you got a strong cell membrane there that's hard to get through. But the real reason cells function and interact with the rest of the cells of your body is they signal each other. And signaling occurs because something occurs at a certain area of the lipid cell membrane that we're going to call a lipid raft, which is a specialized collection of special phospholipids with a little bit of free cholesterol interspersed. But the structural positioning that a phospholipid takes up, if you have several double bonds in that thing, if you've ever seen a 3D view of a phospholipid that's got several double bonds and it takes up an incredible amount of space, so its two legs spread out, and you change the structure of the cell membrane, and that structure of that area called the lipid raft allows certain cellular proteins to locate there. And those are all our receptors that pull things into cells or extrude things out of cells.
So the fluidity of the membrane is highly, highly dependent on the nature of the fatty acids in the phospholipid.
Fluidity and the ability to shelter or let certain proteins be expressed in that area.
Okay, I think we need to take a close look at this because, as he said earlier, this is very crucial. Okay, it's very important to understand this because downstream, if we don't understand this, we might get a lot of things mixed up. So he is defining the lipid raft here. And let's see what he says. It's a specialized collection of special phospholipids. Okay, so he's saying it's phospholipids with a little bit of free cholesterol. All right, and it's these phospholipids that have unsaturated fatty acids, right, that make up the structure that is the lipid raft. So these phospholipids, they're filled with unsaturated fatty acids, according to him. And then in the next part, they talk about how the fluidity of the membrane is important and is due to certain fatty acids, right? And then Dayspring says the fluidity and the ability to shelter or let certain proteins be expressed in the area, because he talks about how the lipid raft is important for holding proteins, especially receptors. So they're talking about how the fluidity seems to allow for this sheltering. So now let's look at this paper from the Journal of Clinical Investigation, 2002. And this is by Kai Simons, who I think is really the leading authority on membranes and lipid rafts. All right. So let's see what he says in this paper. The difference in packing is due to the saturation of the hydrocarbon chains in rafts, sphingolipids, and phospholipids. So rather than unsaturated fatty acids, he's talking about saturated fatty acids in the raft, as compared with unsaturated fatty acids in the liquid disordered phase. Whenever people talk about membranes, you're going to hear them talk about liquid ordered phases and liquid disordered phases. The liquid ordered phases are corresponding to the rafts, okay? And the liquid disordered phases are the other domains of the cell membrane. So here's a diagram that I think will be helpful. You can see the lipid raft here in the center of the diagram. And note that the lipids here are saturated, right? The orange lipids here are saturated. And then on the sides, in the liquid disordered phase, we have the unsaturated lipids. Now, take a look also at the cholesterol. You will see that there's a lot of cholesterol within the raft structure, okay? And much fewer cholesterol molecules outside of the raft. So rather than have a little bit of free cholesterol, the raft structures are actually packed with cholesterol and sphingolipids. And we'll see here, lipid raft domains are usually defined as small, highly dynamic, and transient plasma membrane entities enriched in, here we go, saturated phospholipids, sphingolipids, glycolipids, cholesterol, and so forth. Enrichment of these hydrophobic components endows these lipid domains with distinct physical properties, including increased lipid packing and order, and decreased fluidity. So when we say liquid disordered, that's the same as saying that they have a lot of fluidity. But when we're talking about the rafts, we're talking about increased order, liquid order, and less fluidity. And the reason for this is, as they mentioned, the lipid raft is important for holding proteins and for holding receptors. Now, these are oftentimes very, very big, massive proteins. Some of these receptors, cross the membrane several times, right? And so they need a significant solid structure, stiff structure, where they can sit comfortably. And the sphingolipids, usually sphingomyelin, the sphingolipids and the cholesterol provide that, right? Every time you see a lot more cholesterol in that part of the cell membrane, that part of the membrane is going to be stiffer. It's going to be more rigid. It's going to be less fluid. And this is important to hold those receptors. Very crucial there. And this is from the Journal of Virology in 2007. And again, he was saying that it has very little cholesterol, but you'll see cholesterol is a critical structural component of lipid rafts. And depletion of cholesterol leads to disorganization of lipid raft microdomains. This is one from the Journal of Biophysical Chemistry, 2016. It's called "The Stability of Lipid Rafts-like Microdomains is Dependent on the Available Amount of Cholesterol." And they say, results show that the addition of cholesterol significantly increased both the amount of insoluble lipid rafts-like structures and their stability. And the availability of a minimum amount of sphingolipids was necessary to produce larger amounts of more stable structures. However, the addition of phospholipids actually hindered the formation of lipid rafts-like assemblies, and those formed were generally less stable. So again, these lipid rafts are chock full of sphingolipids that associate very well with cholesterol. And then we have a lot of cholesterol in there as well. And they provide a rigid structure to hold a lot of these receptors and big proteins. And since they were talking about receptors, I thought we'd look at lipid rafts and insulin signaling. This is from Endocrinology and Metabolism 2002, put out by the American Physiological Society. So we've known about how insulin signaling is dependent on lipid rafts. This is another paper from the same year, 2002, dynamic association of human insulin receptor with lipid rafts in cells lacking caveoli. And they say in liver-derived cells lacking caveoli, autophosphorylation of the endogenous insulin receptor is dependent on RAF lipids. So the functioning of this insulin receptor is dependent on RAF lipids. Here's a more recent study. It's called Phospholipid Exchange, shows insulin receptor activity is supported by both the propensity to form wide bilayers and ordered raft domains. Long name. But basically, what they're saying is that when you have more of the sphingomyelins and raft structures as compared to the disordered or fluid parts of the membrane, which contain more of the unsaturated fatty acids, they found that the propensity of lipids to form ordered domains, rafts, is required for high insulin receptor activity. Now, a lot of times you might hear of studies that suggest that the use of statins is actually associated with diabetes, a higher risk for diabetes. And yes, it's important. No, it's not. No, it's just something we don't understand. And I like mechanisms, right? So I'm like, well, is there a mechanism for that? Now, I'm not saying that this is the mechanism, so please don't go there. We don't want to be extreme, and I don't know. But this is something to think about, right? When we're thinking about what happens when we deprive the cell of cholesterol, when we deprive certain domains of the cell membrane with cholesterol. And again, this doesn't happen all the time, but under certain circumstances, when we are able to lower the cholesterol to the extent where it might impact the RAF structures, then we could have some actually lessening of insulin activity, insulin receptor activity, resulting in poorer, glucose management in the body. So my clarifications for this part, and this is really important, we want to remember that lipid rafts are more rigid, okay, than other domains of the plasma membrane. And they are packed with saturated fats and studded with cholesterol and sphingomyelin, right? And put that in. But the loss of cholesterol from the lipid rafts results in dissolution of the lipid raft. And the higher the amount of unsaturated fats, the higher the loss of function of receptors, such as the insulin receptor. Okay, so again, I know that I do go on a little bit about some of my favorite topics, and I do really have a lot of interest in signaling and lipid rafts, but I think this is an important point to make.